All right, guys, let's talk about bond types. Two different types of bonds that we're talking about in chemistry class are bonds that occur between metal elements and nonmetal elements. We call those ionic, and then a nonmetal element bonded to another nonmetal is called a covalent. That's what we know so far. Okay, but we can sort of further classify these things in terms of their bond strength. It turns out ionic bonds are stronger than covalent bonds, but not all bonds are of equal strength. Okay, so we have to understand something called electronegativity. And electronegativity is just a sort of a measure of how likely it is for an atom to gain an electron. And so we have this table of electronegativities here. It looks like the periodic table, but it's a little bit different. It's the same setup, but the numbers that you see here are not the atomic masses of the elements. They are electronegativity values. And these are values that are somewhere between 0 and 4, okay? And so there's a trend in electronegativity that these are very low over here, and these are very high over here. And the trend in electronegativity just means that kind of as you move from left to right and from low in the periodic table down here to higher up, we have high electronegativity values. So the lowest numbers you're going to find are down here, and the highest numbers you're going to find are up here. Okay. So let's talk about how we can use those numbers. And when you look at a chemical formula that is definitely let's just look at an ionic setup here. Let's look at sodium chloride, and to determine the bond strength of the bond that's holding the sodium ion to the chloride ion, we're going to take the difference in the electronegativity values of both elements. And so sodium, we just find where we usually find it here. Its value is 1.01. And chlorine, we're going to find chlorine over here, and that value is 2.83. And then when we subtract those numbers, it's going to give us, a number answer. So let's do that, 2.83 minus 1.01. That gives us a value of 1.82. Okay, so that number by itself doesn't mean a whole lot, but when you place it on a number line between 0 and 4, because that's the range of the electronegativity values on this table. Nothing is lower than 0 and nothing is greater than 4. And we look for this little cutoff point, and oddly it's not right in the middle, it's at 1.67. And everything that has a difference of 1.67 or greater is classified as an ionic bond. And if you subtract two elements and you find that the difference in electronegativities is somewhere between 0 and 1.67, that's going to be called a covalent bond. Okay, so that's how you use the electronegativity to determine the bond type, and so we can actually see that, let's look at some more ionic compounds. Some ionic bonds are stronger than others. So let's look at, instead of sodium chloride, let's look at something like, how about lithium? How about like lithium sulfide, Li2S? Here we're still just working with two different elements, lithium and sulfur. And so let's take a look at the difference in electronegativity between those guys. Lithium, 0.97. The metal is always going to have a lower electronegativity. And then what I say, sulfur is 2.44. And let's subtract these values. So that's a difference of 1.47. And so wherever your difference falls on this little number line from 0 to 4, the lower the difference, the weaker the bond. The lower the difference in electronegativity, the weaker the bond is. So the bond that holds sodium to chlorine is actually stronger than the bond that holds lithium to sulfur, even though they're both ionic compounds. Okay, and covalent compounds, the reason that we get low differences in the numbers here is that they all come from the same neighborhood of the periodic table, and the electronegativity values are likely to be pretty similar to each other. So you're subtracting numbers that are similar and you're going to get a pretty small difference. And that puts them somewhere between 0 and 1.67. Okay, so that's how determining bond strength works.